Hello everyone, this is Shweta Patil. Welcome you all to the video lecture on computer organization. In the previous videos, we looked at different concepts of the first module. Now let's discuss about the different concepts in the second module, that is input-output organization. Okay, here in this module, we will be discussing about how program is controlled by the IO operations of the program are controlled, that is how program control IO is done. Then about interrupts we'll be discussing, about direct memory access, the operation, how direct memory operation will be done, about the transfers of the data using synchronous and asynchronous buses, then about different input output interfaces, and bus standards such as PCI, SCSI and USB. Okay. So now in this video I will be discussing about the first concept, that is accessing of the input output devices. So the most basic feature of a computer is the ability to exchange the data with the other devices. Isn't it? It should have an ability to communicate or exchange the data with the other devices connected with it. Communication is thus established within the computer or in between the computers and the other different types of computers. So in order to establish communication, firstly it has to communicate with the different devices which are connected to it. So we have to learn the different ways in which the input-output operation can be done, and that itself is accessing of the IO device. The first basic model of how transfer IO operation is done in between the processor and input-output devices is shown here. Okay. So here you can see bus is used in order to connect the different input-output devices. Processor, memory, input-output device 1, 2, 3 likewise until n number of devices, n number of input or output devices can be connected. How they are connected? They are connected by making use of the bus. So all the devices can exchange the data in between them. The information can be exchanged through the bus only. So this bus will be consisting of 3 lines. In the next diagram you will look at the 3 different lines within this bus. The 3 lines are address line, data line and control line. So all the devices which are connected will be assigned with a unique address. So device 1 may be an input device or an output device. It will be having its own address. Device 2, it will be having its own address. So unique addresses will be given to each of the devices which are connected to the bus. So during the start of any of the input-output operation, usually the processor will be sending the address of the device with which it wants to communicate. Okay. So what it has to do? It has to send the address on the address lines, isn't it? See, what it has to do is it has to send the address on the address lines. So this address will be decoded by different devices, because all of the devices will be looking at the address lines. They'll look at whether it is its own address. If the device finds that it is its own address, then it will recognize it and responds to the commands on the control lines. The commands will be sent on the control lines, isn't it? Then the processor will send a read or write operation and the request data will be transferred. Whatever the data requested by the processor will be transferred. See, if it is a read operation, what will happen? It will be sending the address of the device with which it wants to communicate, and the device will be recognizing that it is its address, and whatever data the processor has asked, that data will be sent to the processor. The processor will read it. If it is a write operation, then what happens? The output, the processor along with sending the address, it will be sending data also, so that the output device will be displaying or outputting it. Likewise, the transfer of the data will be done. Okay. So figure is showing the input output interface for the input devices. See, what all you are looking at, you are having 3 address lines as mentioned. 3 address lines are there 3 lines are there under the bus. One is address line, the other is data line, and the third one is control line. Okay. You can also see See, you can also see the I/O interface. It consists of address decoder, control circuit, data and status registers. Okay, what all it is containing? Address decoder. Why it is necessary? The address will be kept on the address lines by the processor, and that has to be decoded so that the device will come to know whose address it is, isn't it? And that is done by using the address decoder. So address decoder, what the address decoder is doing? The address decoder is decoding the address, and it enables the device to recognize its address, right? So what the data and status registers are doing? Data register will hold the data. Status register contains the information related to the operation of the input output devices. What control circuit will be doing? Control circuit is required to coordinate the input output transfers. What all input output transfers are under process, so all those are to be coordinated, and that can be done by using the control circuit. So this interfacing or accessing of the I/O is making use of memory mapped I/O. What it means? Memory mapped I/O means the input and output devices and the memory both will be sharing the same address space. The same space will be allotted for both input output and also for memory. So the same address space is shared among, and that's why it is named as memory mapped I/O. Memory and I/O both are mapped on the same space. Okay. So the input devices and memory will be sharing the same address space, and that is named as memory mapped I/O. Here read and writes are interpreted as commands to the I/O devices. With memory mapped I/O, any machine instruction can be used for I/O transfer. In order to perform the input output transfer, I will be making use of the machine instruction. Which type of machine instructions you can look at? See, here are the machine instructions. Move data in comma R0, move R0 comma data out. All these are the machine instructions which can be used. Here what happens? Data in is the address of the input buffer, wherein move data in comma R0 will place the data from the data in register to register R0 of the processor. So data in is what? It is the buffer register within the input device. In our example, it is keyboard. Okay. So from keyboard, it has to take the data. Where the data will be stored in the keyboard? It will be stored in data in register. From there, the data will be moved to R0. R0 is the processor register. Okay. Thus, the transfer of data is done in accessing input output, that is by using memory mapped I/O. Okay. Next, you can also take out, if at all I am having outputting display device, okay, printer, right. So what happens there? Data out is a register, buffer register, which is used in order to store the data at the output. Okay. So move R0 comma data out, what will be done? The content of R0 which is read and stored in the processor register is now moved to the output register data out, which is now moved to the output register data out. So it is moving the content of R0 to the data out register. See, we can see in this concept we can look at the 4 different registers which are necessary for data transfer. Which are the 4 different registers? Data in, data out, status and control. These are the 4 registers which are used for transferring the data. In this concept, for transferring the data, I am making use of these 4 registers. So data in is a buffer register which will be holding the data which is inputted from the keyboard. Data out is holding the data from the print, that is holding the data which is sent by the processor at the output device, at the display. Okay. Then status is a register which is containing different 8 bits. Some of the bits are shown here in the diagram: S in, S out, K IRQ and D IRQ. S in is status input, S out is status output, K IRQ may be keyboard interrupt request, D IRQ is display interrupt request, likewise. Then one more register whichever you are having is control. Control is shown with only 2 bits inside, KEN which is keyboard enable bit, DEN is display enable bit. So all these are the registers which are used during the input output operation. Okay. So all the devices which are connected to the bus, we have looked at in the prior diagram, we looked at different devices are connected to the bus and all those are operating at different speeds. Yes, maybe keyboard may be working with a slower speed because the speed with which the keyboard is working or the speed of the input device now is dependent on the user who is using it. He may type a key now and after 5 seconds he may type one more key, or immediately one after the other he may go on typing. So, speed will vary for keyboard and it is a slow device. Now, with respect to display, for displaying the processor will be sending the data very much faster at electronic speeds, but display is done with some of the characters at some time. So, this is the difference in speed between the processor, memory, input and output devices, and there should be a way to synchronize this. Already all this is discussed in the first module, last topic, isn't it? So, there in order to synchronize the speed, what they did is data in is a buffer register which is used in input device and data out is the buffer register at the output device. SIN is used as status flag for input, that is for keyboard, and SOUT is as status flag for display, that is output device. Okay. So, whenever a character is typed from the keyboard, it will be stored in data in register. When character is read from the keyboard, it will be placed in the data in register and SIN will be automatically set to 1. The processor will be continuously monitoring this SIN bit, and when it checks that SIN is 1, it will start to read the characters from the data in register and place in one of the registers of the processor, isn't it? So, this can be seen in the program itself is written here. You can look at, see, move hashline comma R0 means R0 is a pointer which is made to point to the some line, okay, some address of the memory. Line is the address given to some memory location. So, test bit hash 0 comma status, what it is doing? Status is the register and 0th bit of status you can look at. What is the 0th bit of status? It is SIN, isn't it? So, SIN is now checked, testing the bit 0th bit of status. If it is 0 means what? If it is 0, data in register is not full, it is empty, means no character is there. If no character is there, is the processor reading it? No, it has to wait, isn't it? So, it will be entering into wait state, wait k test bit hash 0 comma status, that statement itself will be executed repeatedly. Branch equal to 0, wait k means if this test bit status 0th bit is 0, it will be under wait state. When it becomes 1, whenever a character is placed in data in, it becomes 1. When it becomes 1, what happens? Move data in comma R1 will be executed. That is, whatever is there in data 1 will be moved to the content of a register within the processor. Thus, it moves the content data in comma R1. So, in order to output the data, outputting of the data, how it is done? By making use of data out and SOUT. Data out is a register, buffer register within the display device. It will be full when processor sends the data, and whenever it is displayed, it is made empty, isn't it? When it becomes empty, again it intimates the processor to give the data in. Okay, that is depicted by using SOUT. So, how it is tested? You can look at the first bit. SIN is the 0th bit, S1 is the first bit of the status, isn't it? So, the first bit of the status is checked. Branch if equal to 0, if status SOUT is 0, then it has to wait. When SOUT becomes 1, that at that time branch equal to 0 becomes false, right? At that time content of R1 will be moved to data out register. Okay. Now, move R1 comma content of R0 plus. So, content of R0 is now placing to line, it will be incremented, one character, so it has incremented to next place. Within line itself, it moves to the second, it has to store the second character, so it moves, it will be incremented, line plus 2 assume. Okay. Then it will be checked whether it is end of the line, or end of the characters, all the characters, that will be checked out. Carriage return, whether carriage return is there or whether it is end of the line, that will be checked out by the rest of the code. Okay. Until and unless it reaches the end of the line, the above two statements will go on executing because call process is there. Okay. So, it goes on executing the two. it will be checking for input. If input is ready, if SIN is 1, it will be taking the data from SIN, store it in some register. The content of that register will be outputted, that is will be displayed whenever the display will be free, isn't it? Likewise, we are performing the input output operation. Yes, input output of the characters in order to read and display a line of characters is done by using this program. The rest of the topics I will be discussing in the next video. Thank you.